Okay, so the reason I'm telling you this is we need to use a z-distribution, right? For the interval estimation for population proportion. Okay, the same thing. The idea is the same. Idea is like, let's say we have a oops, this is too thick. I'm gonna delete this. I usually don't really use this thick pen. Okay, so let's say we have populations, right? This is populations, and then we need to get the samples, right? Let's say we have a sample. Let's say sample size is, for example, 30, right? And then we can get another sample, right? Another samples, and we get another samples, and etc. And let's say we have a sample, right? And then we can compute what? We can compute the sample. What? We can get from the sample, we can get the sample proportions, right? Let's say today's election day. So for example, let's say for this sample proportions is, for example, let's say from this sample, by the way, let's say about 48% of people, voters, right? They support Donald Trump, right? And let's say, right? So, and from this samples, it's different, right? Let's say from this sample is n is a 30, and we know that from this samples about 0.51%, like 51% voters, right? They support Donald Trump, right? So we have different samples, sample proportions, right? So from this, we can compute what? A sampling distribution of the sample mean, right? So we know that this is what? This is follow the normal distribution. So by the way, this is sampling distributions, right, of sample proportions, which is p bar, right? P bar, right? P bar. And we can get p bar here and etc., right? And we know that this mean, right, is p, which is population proportions, right? But the problem is we don't know the population proportions, right? This is unknown, so basically the same thing. You know, from, let's say from this sample, right? Let's say from this sample, we need to estimate the population proportions. So the idea is exactly the same. For the confidence interval, right? We need to calculate what? Point estimate and plus minus marginal error, right? And you know that this point estimate is basically you can use sample one of like sample proportion, one of them, right? So this is p bar. We can, so that's a point estimate, right? And then plus minus marginal error, and then plus minus. And what is the marginal error? The equation for the marginal error is, I mean, okay, let's just, and then this is like a z critical. Z value, which is alpha divided by 2, right? And you know that alpha is a level of significance. And this time we are not using the t distribution. Okay, so that's the difference between what? The previous case we use a t distribution, right? For the sample mean. But for the sample proportions, we use a z distribution, right? Because we don't have to really use the population standard deviation. And then multiply by basically standard error. Okay? And so standard error, right, is basically, so let me just expand a little bit, and plus minus and z and alpha divided by 2 multiply. The equation for the standard error is the basically it's the what? Root n and the p bar, right? And then it's 1 minus p bar. Okay. So by the way, this is the this is actually the standard. Okay. Okay. Maybe okay. I'll just show you everything. What happened is the exact standard aviation is n, right? And then what? The sigma, right? Hold on. I think the okay. this is okay. You know what? I mean, you don't have to really know this detail, but I'll tell you all the details. But later on, I'll tell you what you need to know. Okay. So the standard error, right? So okay, I'll just tell you exactly. So I mean, you don't have to know this detail, but oops, why can I use the eraser? Okay, you don't have to know this detail, but I'll tell you anyway. The exact equations. Okay, and the point estimate plus minus marginal error, right? And then this marginal error, right? And then this is, we can expand this as z alpha divided by 2 multiply by, and then standard error, right? You know the standard error, it's the basically it's z alpha divided by 2 and then what? The sigma of p bar, which is standard deviation of the sampling distribution of the sample proportions. Okay, and this is equal to, and plus minus z alpha multiply, this equation for this is what? Is root n and then p minus 1 plus p, right? However, the problem is we don't know the population proportions, right? The p is unknown. So what we have to do is we need to come up with an estimate, right? So this is why it's called interval estimate, right? So this is like a p bar plus minus z alpha divided by 2 multiplied by, instead of a p, right? We can use the population proportions. I mean the sample proportions here, p prime, right? So the estimate, so we have to use a p bar and then 1 minus p bar. Okay? I know it's so long. I mean, this is, by the way, this is exact mathematical presentation. However, right, for you, you only need to know the result, right? Result is for to calculate the confidence interval, and this is it. That's what you have to know, and that's why you have to use for your homework assignment and for the test, right? Okay. So for the point estimate, you're using the population. The sample proportions, right? We use sample proportions, and then plus minus, and z value multiplied by root p bar, right? And multiply 1 minus p bar divided by n, and then you apply the square root. So that's the equation. Okay. Now I'll show you one example, right? Okay. By the way, for this z value, right? By the way, this is z value, right? Same thing. For the 95%, you're using what? 1.9599, and for the 90% CC, right? You use 1.6448, which is 1.65, and for the 99%, your z value is what? 2.575, right? So that's your z value. Okay. Okay. Now, let's just use one example, right? And let's take a look at this data. Oops. Oh, sorry. So let's take a look at this data, right? Go to the data, right? And then download this file. Okay, so I'm going to enable editing. Okay, now this is the data file, right? And let's take a look at this example, right? I think this data is about what? A following example illustrate the computation of the marginal error and so okay. So national survey of 900 women golfers were conducted to learn how women golfers view their treatment at golf course in the United States. And the survey found that about this number of women's golfers were satisfied with the availability of the tee times. Okay. So the point estimate of the, okay, so basically this is like a sample is what? There are 900, right? Among 900, how many? About 396 the women golfers, they are satisfied, right? So if you look at this data, right? And then you have responses, right? And you have responses and yes, and it's a 900, right? So it's probably, I think it's so okay, so 901. So yes means they are satisfied. No means what? They are not satisfied. Okay. So first we have to find, right? We have to find n, right? So just go back, right? And let's say we have to find n, right? So which is a count for response. So that's n. Okay. So the count for response, you can have what? Okay, so the count for response. Let's see, and then that's not n. Okay, sorry. So we have to have a sample size first. That's the n. Okay, and then count of response means like how many of them are said yes, right? Okay, so let's say n. To find the n, I think you can use a count functions in Excel, and you cannot use just simply count. You have to use count a. So basically, it gives you the number of in this case, it's number of data which are not empty. So that's why you have to count a. It's not empty, right? And let's see. Count a, right? Let me just expand this a little bit. Okay, so the count a, right? And then it's starting from A2, and I think all the way, I think 8901, right? The last one is 8901, yeah. So it's 900. So A901. Okay. Okay, so we have our 900 samples, and then the count. I mean, it's the response, right? It's not the count. I'll say response. Response of interest. Response of interest is what? So yes, right? That's why very interesting, right? And so this is yes. Okay, and then what else? And the count for response. So we need to count how many yeses, right? And for that we need to use a function called COUNTIF, right? COUNTIF. Okay, and then starting. So basically, we need to from A0. I mean A2, right? And all the way to 809, the last one. Not actually 901, right? So that's the last one. And then we need to basically we need to count how many yeses, right? So in the second argument, we have to say yes, which is E2, right? So yes. So basically this will count a number of yeses. So about 396, and not about 396 women golfers say yes, right? And then now from there we can compute the sample proportion, right? The sample proportion is basically what? 396, which is a count for response, which is E3, right? Divided by the sample size, which is D1, right? Oops, what happens? Oh, E1, sorry. Not D1, E1, right? So 396 divided by 900. Okay, so about 44, not about, sorry, it's 44% women golfers say yes. So that's the sample proportions. And so the confidence interval, I think, is 95%. Okay, so the coefficient CC, the confidence coefficient, confidence coefficients, right, is, which is CC, is 0.95, right? And the level of significance, level of significance, which is alpha, right? The level of significance is 1 minus, it's equal, right? 1 minus what? The E6, right? So that's like 0.05. Okay, now we can find that we need to find the z value, right? But we don't have to really find the z value. Why? Because we know that for the 95% confidence, our z value is what? 1.9599, right? We know that, but let's just compute. Although we know, we can use a 1.96. Let's just use the Excel spreadsheet, right? To just, okay, it's a norm. I know that this should be 1.96, but norm.s.inverse, right? And then 1 minus, right? We have to use the level of significance divided by 2. So that's important because we are talking about the two-tail, okay? And so what? Which is E7, right? E7 is a level of significance alpha divided by 2. Okay, so it's 1.96. We don't have to compute this, but I did it anyway. Okay, so we have a z value. Now we need to find the standard error, right? So the standard error is what? Let's go back. Your standard error is basically, okay, so let me just, so you know that this is the standard error. This is a standard error, right? And then the whole thing is the marginal error, right? So the marginal error is basically z value multiplied by what? Standard error, right? So what I'm going to do is I'm going to first compute the standard error. I'm going to first compute this standard error, right? Then later on I'm going to compute the marginal error, okay? So for the standard error, right? The standard error is what? How can you get the standard error? Standard error is basically, oops. Hold on. Okay, so standard error is the, okay. So square root, right? And then what? The p prime, the p bar multiply 1 minus p bar divided by n, right? So what is a p bar here? Is a sample proportions, right? Which is 0.44, right? E4, and multiply by 1 minus E4, right? And then you divide it by n, which is the sample size n, 900, right? Okay, so that's it. And that's your standard error. It's a 1.16. Let's see if that's right. Just want to check. Do they really shows that? No, they don't really shows. Okay, but we can check the marginal error later on. Okay, so the marginal error, right? ME, the marginal error is what? Is the standard error multiplied by z value, right? See, the marginal error is z times standard error, right? So that's what I'm going to do. I'm going to is equal the what? Z value multiplied by standard error, right? And which is 0.032. Yeah, 0.032, right? Good. So that's a correct value. Okay. Now we have a marginal error, right? So now we can find what? We can find, so what is a point estimate? Our point estimate is basically the what? The sample proportion, right? The sample proportion, this value, right? And then lower bound is, or the lower limit or lower bound, same thing, is what? The point estimate minus the marginal error, which is this guy. Okay, so that's the lower limits, and then upper limits or upper bound is equal your point estimate, which is sample proportion, right? And then what? This time is a plus the marginal error. Okay, so this is how you can find the lower limits and upper limits. Okay, and that's the example that I used. That's the example I actually used in the textbook. So this is your textbook. Okay, so basically I'm done with this the interval estimate for the population proportions. Okay, so any questions? So any question? Good. So I'm done.